Hey everyone, and welcome to the session on AZ-900 Live, where we focus on Azure fundamentals. And this is the first episode in the series, and I'm super excited to bring you this training and go through this course section at a time with you. And there's some great goodies for you in this course, so stick around because we've got some great stuff for you to grab along, as you follow along with me. Now, the focus of this first episode is going to be to give you an exam overview. So if you're just starting out in your AZ-900 journey, this is a good place to begin. And then we're going to go through the very first section of cloud concepts. And every week, we will continue to bring you more and more episodes to get you started in Azure. And this is just a time a lot of people are trying to reinvent their careers, get things going. I just hope this helps you. This is a completely free series, and I think you'll like some of the other freebies that we're giving along with this as well. So let's begin. Let me get right into it. Well, about the series, how did it come about? Well, this was based on student requests. A lot of people love our training courses, but they wanted something a little bit more interactive where they could submit live questions and get response from the Skylines Academy team, sending questions beforehand that I can then put on the show here for you. And so that's really what it's about. I know a lot of people want to get the certification and learn Azure, and this is how we begin together to do that. It starts with the AZ-900 exam, and we will hopefully, cover AZ-104 and other exams in the future, but this will run for a number of weeks as we focus on AZ-900. And the videos air every Friday at 12 p.m. Central Standard Time. It's about 6 p.m. for those of you in the UK, 1 p.m. Eastern Standard Time. Hopefully you can calculate from these times where your time zone is. And again, submit your questions each week. If you join the Facebook group for Skylines Academy, it's called Azure Study Group Skylines Academy, you will see in there that we post a link to questionnaire. You can just pop as many questions as you want in there, and we will try to get them answered. More importantly, just leave them in the comments below in the YouTube channel as well, and we'll get to them there as well. So many ways we can answer your questions. So don't forget to hit the like button, just like every other YouTuber out there. I'm going to start asking people to do that, and please subscribe as well, and you'll get notified every time an episode gets released. And like I said, they premiere every single Friday. With that, here's your first freebie. As a thank you, you can have the entire training course. So you hit that like button, you hit the subscribe button. We're going to give you the entire AZ-900 Skylines Academy training course completely free. That's over 5 hours of training online on demand. Link is in the description in YouTube, but I'll just show you that real quick. If I head over to my browser here and tab over, this is our course at courses.skylinesacademy.com, and this is the entire course you'll get access to. So it's got all the cloud concept lectures. You'll see some of those slides. I'm going to use them here throughout the live demonstrations. Azure core services, all about compute, networking, data storage services, other services, identity, compliance, security, cost, all of that. You're going to get the whole thing completely for free. So just use that code AZ900YT, and you will get the course for free. So let's begin. Let's start with an exam overview and some tips around that. Well, the first resource you need to be aware of, I'm going to switch over to my browser again here, is the Ultimate AZ-900 Azure Fundamentals Study Guide. So I've pulled together a ton of resources here with the Skylines Academy team. It's been updated for the latest exam updates that came out on May 28th, 2020. So everything is up to date here. And if you go through this, you'll see, first of all, we have an exam description. And let's talk about this a little bit for those of you, getting started, with AZ-900. And Microsoft states the following, right? Candidates for this exam should have foundational knowledge of cloud services and how those services are provided with Microsoft Azure. The Azure Fundamentals exam is an opportunity to prove your knowledge of cloud concepts, core Azure services, Azure pricing, SLAs, lifecycle, and the fundamentals of cloud security, privacy, compliance, and trust. So even for a fundamentals exam, you can already see there are a lot of sections to cover in here. The exam is intended for people beginning to work with cloud-based solutions and services, and candidates should be able to demonstrate a fundamental knowledge of cloud concepts as well as Azure services, workloads, security, privacy, pricing, and support. So again, you have to be able to demonstrate that fundamental knowledge. There's not a lot of hands-on labs as you'll find in this exam, but you do need to be familiar, as it says there. In addition, you should be familiar with concepts of networking, storage, compute, application support, and application development. Azure fundamentals can be used to prepare for other Azure role-based or specialty certifications, but it is not a prerequisite for any of them. So there are a lot of other, certification tracks. You can check out one of the other YouTube videos. We already covered that. We went through all the certification options live, and took a lot of questions from students on that. So if you're just getting started and want to know about all the certification roadmaps, they're there. But you will find the basis for all of those. It's optional, but a lot of people do it, is AZ-900. So this is the place to begin if you are just getting started. Now, one question we get often is, how long does it take to study for the AZ-900 exam? Now, I mentioned it's a beginning exam, but there's still a lot in there, and you should be prepared to put some effort in. Now, we do have a training guide here, and I'll go through some of these exam breakouts in a second, but I encourage you to sort of click the link here and grab the spreadsheet for the training calendar. And there is a 1 week calendar I put together by talking to some students who managed to cram through in 1 week. So if you've got a week and you want to do it in 1 week, you absolutely can do that. Go through the course, follow everything that's in this training calendar. You essentially, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, cranking through, practice test Sunday, and go and take your exam the following week. But you have to obviously be committed to that, have a plan in place. You don't have to do it in 1 week, spread it out over 4 if that's more manageable for you. Obviously, I don't know what your time commitments are, but set it as a goal, put a date there, book the exam, and go for it. But let's go ahead and look at the different sections of the exam here. And you can see I break them out here in this blog post, but let's just go to the AZ-900 website and talk through them a little bit more. And you'll see here, this is Microsoft's page about the exam. And if you scroll down, you'll see the skills measured section here, and you can click here to download the skills outline. So let's go through this in a little bit more detail here. So if we scroll down, describe cloud concepts. And this is where we're going to focus on, the first part of today's session. Once I've gone through the exam overview, we'll get into detail of this first section. So you can see describe cloud concepts. 15 to 20% of the exam will have questions that focus on describing cloud concepts. You need to describe the benefits and considerations of using cloud services. Now, keep in mind, it says describe. You don't need to completely be hands-on with them. You need to know what they are, when they're used, what the terminology is, what it means. That's the important piece. And you'll find that a lot throughout this exam. Again, they're not expecting you to be a day-to-day admin. Hopefully you move on and you get that job if that's something that you're looking to do. But this is the fundamentals, just making sure you know how to describe the term. So the first section here, the benefits and consideration of cloud services. This is if you're brand new to cloud, like, what is HA? What is high availability, scalability, elasticity, agility, fault tolerance, disaster recovery? We're going to talk through those in detail as we go through. Describe economies of scale, capital expenditure, operational expenditure, the consumption model. We'll get through it all today, like I said, but core concepts that are just about cloud. Then they go on to say, okay, describe the differences between infrastructure as a service, or also known as IaaS if you're new to the term, platform as a service. You'll often hear people talk about PaaS, and software as a service, which people say SaaS. So you'll need to describe all of those. In the next episode, we'll go through that. Describe the differences between public, private, and hybrid cloud models. That's where you've got, say, on-premises. That's often attributed to the word private cloud. Public cloud like Azure, AWS, and other providers. And then hybrid is what a lot of enterprises today have, where they've still got data centers that they own, but they're moving a lot of things to the public cloud as well. So that's the first section. Again, describing these concepts around cloud. Then we move into describing core Azure services, and this is now 30 to 35% of the exam. So you can see a lot of weight is put in here on the exam. And here, this is all about knowing the Azure architectural components such as regions, availability zones, resource groups, the Azure Resource Manager, and then you get into all the products. Azure has so many products: virtual machines, scale sets, app services, containers, app gateways, networking concepts, databases, all of it's there. We're going to get through those. That's going to take a few weeks. There's a lot to cover there just to make sure you understand all of those. Then you go into solutions on top of that, things like IoT, big data, machine learning, other things. And then you need to learn about Azure management tools. So that's a big piece, for the exam as well. Then if you scroll down, we'll see here, describe security, privacy, compliance, and trust, 25 to 30% of the exam there. And you can see describe securing network connectivity, core Azure identity services, security tools. Security is at the heart of everything Microsoft does, which is just fantastic. They've created so many tools around it. So we really, really need to, make sure you understand all of these. Again, each of them, like the Azure Firewall, that's a big topic. There are people that just specialize in Azure Firewall. You need to know where it fits, what it does. And I think just going through this course will set you up perfectly for some of the more advanced certifications as well. And then just scrolling down a little bit more, we'll go through all those pieces as we get through. Describe Azure pricing, service level agreements, and life cycles. That's 20 to 25%. And that's knowing how to price out services, what Microsoft's commitment to you is from an SLA perspective, how you think about life cycle, TCO, all those kind of things as well. So as you can see, a lot to cover, and the first thing I do is I would either just print this off or put it on your iPad and just start working through and start cranking through and saying, do I understand this topic? Check it off. Do I understand this topic? And keep going through. And once you feel like you've got it all, take a bunch of practice tests, and then you should be, good for the exam. So that's the goal. That's what we're going for, getting through this entire curriculum. And the great thing is a lot of people over time have said, I don't believe in certification, those kind of things. This is great because whether you take the exam or not, just going through all of this, you are going to be able to have much more mature conversations with other people in IT. You'll know more about Azure. You'll be able to, advance the cause, so to speak, and really advance your career irrespective of whether you have the certification or not. But I encourage you, take it, get the badge, show it off, tweet it, LinkedIn, share it, all those kind of cool things you get to do with the bragging rights that come with any certification. So with that, let's jump over to the PowerPoint slides again, and let's begin walking through understanding cloud concepts. And let's just begin by looking at the first part of the section of the course that we talked through a little bit there. And we're going to cover these 4 things. So we're going to talk about it now, we're going to go through it in detail, and then at the end we'll do a recap, make sure we've covered everything and summarize. So number 1, we're going to focus on describing terms such as HA, scalability, elasticity, agility, fault tolerance, and disaster recovery. 2, we're going to describe the principles of economies of scale. 3, describe the differences between CapEx, capital expenditure, and operational expenditure. And 4, describe the consumption-based model. And that's the order they give it to you in the curriculum. We're going to jump around a little bit, but let's make sure we cover all those things as we go through. So let's just talk about cloud computing first of all and where it came from. And depending how long you've been in IT, is this your first foray into computing, or have you been worked in data centers for a while? You may not be familiar where cloud computing came from. And for a long time, we had a data center and we had essentially the rise of virtualization. So think back a little bit. When an application team that wanted to install some software, much like think about you might install something on your laptop, let's say they wanted to install something on a server to run 24/7, they would come to IT, and IT would typically go and purchase a server from, say, Dell, HP, some of the other big manufacturers, rack and stack that server, and then go ahead and install the operating system on it, so Windows or Linux being the most common, and then go ahead and install the application on there. People would log into the machine, install their software. For a while we had CD-ROMs and everything, disks, but then over time obviously technology continued to advance. And then what happened with the rise of VMware, fantastic technology. They said, we have all these servers running out there, but some of them are running at 5%, 10%, 50%, others. We keep buying new servers every time we want to install a new copy of Windows or Linux and then install our software on there. What if we could kind of pull some of the hardware? It feels like a waste. And so VMware came around, developed what's called the hypervisor. Essentially, you install that on the server first, and then you install your operating systems on top of the hypervisor. So they're virtual machines. They feel like individual machines, like they were physical, but they're virtual. They all run on the same piece of hardware, but they run just like a physical machine would. And then what's happened is the rise of cloud computing. Essentially, people have said, well, okay, well now we can, essentially rent out this capacity. In some cases, people were building data centers and, giving managed services for VMs. They still do that today. It's still very common. This ultimately led to the rise of services like AWS and others, but, Azure has come along in a big way. And that is essentially saying, rather than you manage the data center and the virtualization, come to us, come to Microsoft, we can do it for you. And then, you basically pay for what you use. A common theme you're going to hear over and over again. So another thing people try to use an analogy is think about your electricity. Do you go and build something, on your house, or do you go to a central utility for it? Obviously, that's changing in the rise of solar panels and everything else. But, instead of you sort of everybody building their own power plant, you just rent from the grid, right? You pay for what you use. Think of cloud computing the same way. You're paying for what you use. I want a VM, I want it on demand for 10 hours. You pay for those 10 hours of utilization. So let's go into that in a little bit more detail. Cloud computing is about renting resources versus purchasing hardware. So again, think of the data center. You would buy the hardware. You had all that upfront cost. Even if you didn't put everything on it, use it to capacity, you bought it at sunk cost, you put it in your data center, and you sort of, if you build it, hope they come kind of thing, right? But cloud computing is about renting resources versus purchasing the hardware. You pay for what you use, and all the different services that you use have different pricing models around them that you'll encounter. You run your applications in someone else's data center. A lot of people say like, oh, it's in the cloud. You see all the jokes, everything on the internet these days. But just think about this. There's still a data center somewhere. Microsoft has gotten really, really good at building data centers. In fact, if you sort of Google that, let's just jump over there for a second and just Google like Azure data centers. The Microsoft has a whole big thing on the Azure data center itself. You click this global infrastructure link here, and you can see these. They've got this great video I recommend you watch, and you can see they're constantly building these out. They're, the economies of scale they're able to gain because they're really, really good at it. They've got lots of customers using it. They, their ability to purchase, thousands upon thousands of Intel CPUs and put them in. They're going to get better buying power because of the bulk they're buying. They're able to negotiate really, really good deals. But I highly encourage you to watch this video, which kind of shows you all of the, details. And, it's a great little promo video from Microsoft around their data centers and the trust that they put in. And there's cool things you'll find out about also as you kind of read further into this is, how people are secured, who can get in and out of the data center, how they even allow third-party vendors in there, and the proof and things they have to go through before they can get in there. So, it's amazing what's been done. And so I can't stress that enough. And I think when you just come back to thinking about why we're here, why cloud computing is so important, that this is a big part of it. So let's jump back to our slides here. The cloud provider is responsible for the physical hardware and facilities necessary to execute your work. So again, they are responsible for what they control, right? The physical, the physical cables, the power, the cooling, the hardware, security of the facility, all those things. And you'll learn more as you pursue security certifications about sort of the boundaries of security and the shared responsibility model. Microsoft in the Azure world is responsible for a certain area. You're still responsible. If you install bad software inside your VM and you get viruses and things on your servers, or you leave them exposed to the internet, that's still your problem. You do still have to take security very, very seriously. Don't just assume they're taking care of everything. They're taking care of a lot of it because you don't have to manage that data center anymore, but there are still things that you need to take care of. The cloud provider is responsible for keeping the services they provide up to date. So a good example, again, you'll learn more about PaaS services as we get into core Azure services later on, where they're maintaining like SQL database services for you. They're maintaining, app services and different versions and things. They maintain Kubernetes, Azure Kubernetes service as an example. But you're responsible, when you build a VM, they're responsible for a lot of it, but you're responsible for patching that operating system still. So a couple of things just to keep in mind there. It's not like, you just rent the VM and you're done. You still have work to do on top of it. So core cloud services, there's a bunch of areas these are broken down into, and we do get into them a little bit later on, like I mentioned in the series and in the training course if you're going and taking that. But you've got compute services. These are things like virtual machines, anything that's, where you're running, programs on top of, that's your compute services. You've got storage services like every application, or just, maybe you need to store lots and lots of images. I work with a lot of medical companies. They store a lot of, x-ray data and stuff like that. All sorts of reasons to have a good, large storage footprint, and Microsoft does a great job of providing a rich set of storage services there. Networking services, if we want all our different compute VMs and containers and everything to talk to each other, we still need networking. Microsoft provides networking. There's virtual networking, software-defined networking for us to put in place. Application services and analytics services as well. These are kind of the core groups, if you will. So things like IoT sometimes come under analytics services and networking. Application services are all about saying, okay, well, rather than me building the VM, putting more software on, and then giving it to the app team, maybe there's some services that already come with that stuff already there for you. So really, really cool stuff that, there's a lot of core cloud services there. And again, you're going to rent versus, buy a lot of these services. Now, moving along, one of the core things we have to understand that you probably saw in the curriculum there was elasticity, elastic scaling, scalability. These words you'll often come across. And you'll see as we kind of look at the static scaling option first of all. Think about this black line as the amount of resources. So think about the amount of Intel CPU, amount of memory you basically provide in, the application, the VM, whatever it is. These are the resources you're providing. And then the workload is going to come in and use a number of resources. And the problem with static scaling is that you have to size it enough to account for the peaks. If you don't, you're going to get capped where the workload needs more than perhaps you can provide. And you contrast that with elastic scaling as an example, where you can allocate resources and fluctuate resources as you need to, right? So just given that Azure has so many resources available, they've built these giant data centers, you can put in auto scaling rules where workloads scale horizontally. That means you add more machines, and then users come in and they hit machine A, then A and B, then A, B, C, so the loads are spread around, and then you take away servers over time as the load subsides. And that's the way you can do that. It's called horizontal scaling. And if you keep going, you'll learn more about scale sets and things that Azure has. So that's quite important versus static scaling. When it's not an elastic workload, you will have to go and add resources there. If the workload can't adjust on the fly and is built for elasticity, then you won't be able to take full benefit of these things. But it is a major pattern which benefits from cloud computing because of that consume on demand. You're only paying for what you use. You don't have to buy a ton of hardware just in case you're going to get to that peak, right? So a lot of times people would oversize the purchases because they don't want to have to buy again, right? Because then that's worse, because then they wasted more money. As your workload changes, resources can be changed to compensate. That's up or down, as I mentioned. An example of this is seasonal demand for retail websites. So think about some of the popular fast food chains, Domino's example, others that are out there, Black Friday, all the retailers. These are the examples of companies that get hit harder on certain days, right? So Domino's, when the Super Bowl's on, probably get a lot of pizza deliveries. Black Friday, other retail stores will get their websites get hit very, very hard, as people all rush to purchase, all the deals that are there. So think about it in the context of the business always, and try to keep that in mind. Think about these businesses that you probably transact with daily. How would they benefit from some of these things is a good way to think about it. Scalability then, just to expand on this concept, this is increasing or decreasing resources based on workload demand. There's vertical scaling, as I mentioned, and then there's, horizontal scaling. But vertical scaling is known as scaling up. And then that's adding additional resources to increase the power of the workload. Horizontal scaling, in contrast, that is known as scaling out, and that is where you add more machines. So vertical scaling, think about it as I'm putting more CPUs into a machine that I have. I'm just adding more power to that workload. I'm not adding additional copies of that machine. I'm just putting more power into that machine. Horizontal scaling is about, okay, great, you reach capacity, no problem. You just get your CPU amount. I'm going to add another machine and another machine, and then eventually I'm going to take those machines away when the resource utilization isn't needed, doesn't need that much power anymore. So this is something just to keep in mind, and you've got to think about this. There's vertical scaling, there's horizontal scaling. The difference here, this comes up a lot. I think we've got a question on it, for later on. It'll come up again. Is the difference between elasticity and scalability. Scalability is your ability to add, vertically scale and horizontally scale workloads. Elasticity, think about it more in the context of the workload. What's its ability to scale up or scale out as needed, right? So is the workload elastic? Can it accommodate that? Does it work well in that setting? Because you can still do these things manually, right? You can say, okay, Black Friday is going to happen the week before. I'm going to manually go in and just put a bunch more power into the machines or add more machines. That doesn't mean the workload's necessarily elastic, right? So contrast it, you want to put more automation in, make that workload elastic, make it able to do these things if it makes sense, of course. There is a blog post on that as well, actually, now think about it. If we go back to the Skylines Academy website, so if we pull that up here, and let's go into the blog here. And if you scroll through, there's a lot of posts here we have, so I encourage you to check lots of these out, but we did write one. Let's go through, it's probably on the next one. You can see there's one on high availability there, but yeah, you can see AZ-900 cloud concepts, scalability and elasticity, and this will explain a lot of that for you as well, and just the concept of scaling up versus say horizontal scaling. Great animation there that really depicts it nicely. So going back to our slides, let's continue on. Yeah, hopefully that you've covered that and you feel pretty comfortable. That is something you are very likely to get questions on the AZ-900 exam. Here we are, vertical scaling, powering, making that machine bigger, horizontal scaling, adding more machines. Hopefully this has drummed the point home now. I think I've said it about 3 times now, so there we go. High availability, let's switch gears a little bit. Okay, so we know about adding power, compute power to our machines. What about when things go wrong? What is high availability all about? Well, for one, think about an SLA. So an SLA is a service level agreement. This is an agreement with the business and the application teams on the expected performance and availability of a specific service. So think about it as an agreement with your IT department and the app team, and you're saying, okay, I'm going to make sure that this system is up 99.9% of the year, and it'll have occasional downtimes for maintenance and things like that, but I've got an SLA to keep that up and running. And you've got some general SLA best practices you should be aware of, right? You define an SLA for each workload. You have dependency mapping, so often you'll have workloads that are dependent on other workloads, and you have to also include external dependencies as well. So often, you may have like workload A is dependent on workload B, but then workload B is dependent on some external service. Maybe they pull in data. Maybe it's a weather application, and you pull in data from some of the National Weather Service information. Well, now you have a dependency on something external. So if that service goes down, that can affect your SLA. So again, this is all about your agreement to provide service. Identify single points of failure here. So if you've got one machine that is critical, but if it goes down, everything goes down. How do you resolve that? An example here is a workload requires say 99.99% commitment to the business, but depends on a service that is only available 99.9% of the time. You're not going to meet your SLA, right? Some key terms here. I think this will help bring the conversation home. You've got mean time to recovery, MTTR. So when something goes wrong, there's the average time to recover the service from an outage. That's what MTTR is, the mean time to recovery. You've got mean time between failures. So, okay, so we recovered a service, but what if we have another failure the next day? What if we have not one the next week? Or is it a year between failures? How often are these failures occurring? Recovery point objective and recovery time objective are other key things we hear about, particularly in backup and DR scenarios, right? So recovery point objective is the point you effectively recover to. So if your recovery point objective is say 5 minutes, that means that you can lose 5 minutes worth of data. So say that we back the machine up, or the technology we're using ensures that we can restore to 10 p.m. at night, and then 10:05 and then 10:10, right? Because of the way the software is configured. Well, at 10:04, if something goes wrong, the last backup would have been at say 10 o'clock. So I've lost those 4 minutes between 10 p.m. and 10:04, right? At 10:05, assuming I configured everything correctly, my agreement with the business is 5-minute RPO. So I need to make sure that I can always hit that point. Now that's a very aggressive RPO, just to be clear, but hopefully it proves the point. Now recovery time objective is the time requirement for recovery to be completed before there is business impact. So if something is down, let's say that we can't recover from a failure within 10 minutes. and the business is hemorrhaging money now, we haven't met our recovery time objective if that's what we need. And we've got all sorts of ways to build in technologies here to make things more available, and that's what is critical here. Now think about this from data recovery, disaster recovery and fault tolerance, right? So fault tolerance is about redundancy is built into services so that if one component fails, another takes its place, and this reduces impact when disasters occur. So that means the service is fault tolerant, right? So it's another one takes its place. It's already on standby, perhaps. Disaster recovery is planning for catastrophic failure of workload. This could be region to region failure. This could be on-premises to cloud failure. This requires a lot of automation and orchestration, so you don't have to manually bring everything up. But this is thinking about complete disasters, right? What if something terrible happened to a whole city, for example, it lost power and everything for a long period of time, and you needed to fail over to another region. This is where disaster recovery scenarios come in. Now, HA examples, here's a few for you. A host outage. What happens when an underlying host has a catastrophic failure, right? So you've got your virtual machine that's running on physical hardware in the Azure data center. Hardware fails from time to time, something goes wrong, there's something manufacturing defect that shows up later on in that server. Well, an HA, a high availability example, is where that machine will just automatically get restarted on another host. There'll probably be an outage for sure, depending on how the application's built. Maybe there's two virtual machines running, they're on two separate physical hosts. This one goes down, it simply keeps running, but all the traffic is fed to the other one until this VM is restarted on another host. So that's an example there. Availability sets and zones increase the availability. So even though the VM would get restarted anyway, you can put availability sets or zones, which says, okay, I've got 3 virtual machines. I want them running in 3 separate data centers in the same region. That's availability zones as an example. Cross-region deployment is another high availability example where you can make an application highly available, is to deploy a configuration where you have machines running in 2 different regions. Particularly global applications too, you might have for performance reasons, might want things closer to the users in the various countries, and then perhaps you want to have redundant data centers maybe in the same country or nearby, depending on the requirement. So just think of high availability. This is all about maintaining availability, meeting those service level agreements, things like RPO, RTO, mean time to recovery, etc. All critical. Just make sure you understand the terms and what we're thinking about here. And cloud computing just gives you all these options on demand, which is just fantastic. I've been through so many disaster recovery scenarios before. I got into cloud when I was working in the data center, and we used to test DR. We had twice a year tests with one of the companies I worked at where we would make sure that we could recover in the event of a failure. When a service in one region has an outage, traffic can continue to run in the second region. That's the last bullet there, just on cross-region deployment. So did we cover it all? Well, I think we've covered number 1 now. So let's see, we've got high availability. Yep, we covered that. Scalability, elasticity, agility, just to expand on that. So that's more, it's an interesting term because it gets a little overused in the industry as well now. But the ability to move quickly, make changes quickly, that's one of the things around agility. Fail fast, fail often. That's more on the business side. In the tech side, we think of agility as the ability to just quickly add servers, right? So just think about this for a minute, or not just servers, but anything an app team wants, right? If they want a new virtual machine, or if they want container services, or whatever they want, it was a long process when you had to do that on premises. If you didn't have that all ready to go, you had to go and acquire it. You had to rack it, stack it, then you could eventually hand it over. And it takes weeks, sometimes months, to get things to these teams. By having scalability of the Azure data centers, just the economies of scale that they have, you're increasing the agility, you're increasing your speed, your ability to respond and move quickly as a result of that. Fault tolerance we covered, DR we definitely covered. So we still got 2 and 3 to cover. We described the consumption-based model. I guess just to bring that back home a little more, let's go back over to Google Chrome here, and let's pull up the Azure pricing calculator and just take a look at this straight away here. And you can see here what you can do is you can go in and say, like, click virtual machines, and you can size these things up, right? So I can click here to view what we've got. So pay as you go. And yeah, you can see, I'm not going to go through all the pricing calculator now. It's covered again much later. $152 $57 a month for this machine that's running in West US, Windows, standard tier, instance. These are all the different sizes, and you can see the prices change there. One virtual machine, if I increase it to 2, that price is going to go up, and run in for 730 hours. So this is just to get back to that, back to the slide here for a second. Consumption-based model is you're paying for your consumption. That's essentially it. Back to that utility grid model, we are paying for the consumption, for the use of those resources, and that's different to, again, buying it up front. And we'll hit that more when we jump into CapEx and OpEx here shortly. So let's talk about cloud economics. Well, those economies of scale, that's the ability to do things more efficiently or at a lower cost per unit when you're operating at a larger scale. Microsoft has way more purchasing power, with the, like I said, the Intel chips and everything they're buying, all the servers they put in there, that they're just going to do a better job of it, right, than what we can buy them at. The benefits there, they can pass those economies of scale on to the consumers. They acquire the hardware at lower costs. They even get local government deals in some cases, and they're just better at managing data centers, quite honestly, right? So, and those local government deals, interesting. Sometimes there's incentives, right, where local or state institutions are trying to attract them there. There's all sorts of incentives and deals that can be made as well. So let's talk about CapEx versus OpEx. So CapEx, capital expenditure, that's spending on the infrastructure, when you do it up front, and then you write that cost off over a period of time, maybe 5 years, right? Operational expenditure, you don't have that upfront cost, but now you're going to pay for that service as you consume it. Back to what we were just talking about a minute ago. You deduct it from your tax bill in the same year as the expense occurs, typically there, right? So, OpEx essentially pay as you go. CapEx, pay up front, reclaim the benefits over time. And this is something that every chief financial officer is wrestling with. Yeah, some businesses love capital expenditure. They try to keep their OpEx down. There's ways to basically reserve instances for a number of years and pay more for that, or have commits and things. There's all sorts of things involved here, but essentially that's the difference, right? It's upfront capital expenditure versus operational expenditure, where it's like something you got to pay for every month, like kind of like your Netflix subscription, right? It's a monthly fee you got to keep paying as you go. You didn't buy it once and you keep it. So that's some of the thought process there. Typical on-premises CapEx costs would be server costs, storage costs, network costs, backup and archive costs, and data center costs, including DR, just examples there. So you're going to buy all those things. Typical OpEx costs are the server lease costs, the software and feature leases, usage, demand, cost scaling to hit them quickly there. Probably pretty common sense to a lot of you coming from a IT background, but just understand if you're brand new to this, you're leasing the server, you're paying for the software, you're paying for usage, demand, and scaling. As you scale up and down those workloads, your costs go up, and as you scale down, your costs go down. So those are things to consider. Benefits though, CapEx predictability, very cost effective when you can consume the infrastructure quickly. So if you're going to fill it up, the hardware, you can buy it, immediately put it to use. Great. Maybe in some cases it works out in your favor there. OpEx benefits, try and buy, low initial cost. I think this is the most amazing thing. It's also how we've been able to, operate Skylines as, in a really cost-effective way, is that, we, as users increase, we add more. We haven't had to do this massive upfront cost, right? And so that's a big part, and you'll see a lot of benefits from that. Did we cover it all now? Well, I think we have. I think we've got 1, 2, 3, and 4 covered. We know about economies of scale now in number 2. And then number 3, hopefully you can now describe the differences between capital expenditure and operational expenditure. And so with that, we've already now covered that first section of the AZ-900 exam. And I just encourage you to keep going. Don't forget to get that coupon code, right? And just keep going through. And then every week, I'm going to kind of do it more like this. Give this to you, in the setting. You can ask questions, and just keep following these through, and eventually you'll have covered it all, and then just go and take your exam. So some student questions that come up a lot, right? Let's see what we had here. What's the difference? We talked about this. What's the difference between scalability and elasticity? Well, again, there, think of the workload's ability to scale up and down. Scalability, you just have scalability by adopting cloud computing anyway. You can still manually scale vertically, you can scale horizontally, but if the workload is elastic, it can kind of move up and down as it needs to, because it can take advantage of those scalability options. I think a lot more automation as well. Where will we get more information on VNets, subnetting, and DNS routing concepts? Okay, so some of that is covered in the course. It is a more advanced topic. You don't need to know a lot of it for AZ-900. I do cover it anyway because I do think a lot of people benefit from it. And it is in AZ-104, AZ-300 as well. We'll probably get to networking. It's probably going to be 4 or 5 weeks out because there's so many other things to cover just going through the curriculum. But just go grab the course and you can immediately go and grab that, and I'll try to answer as many questions as I can when we get there as well, so keep them coming. How hard is the exam itself? Well, I think that's an it depends one. Everybody comes at it a little bit differently from a different background. I think if you're coming from the AWS background, you're just trying to get started in Azure, a lot of the terms are going to be familiar. If you're coming in from on-prem, you're probably going to nail it pretty quickly. If you're brand new to cloud, I can't stress enough, get experience as much as you can. But this exam is definitely the more entry-level one. I think a lot of people do get through the training in a week. Some people take 4 weeks to make sure they read everything and be thorough in it. And I can't give you a straight answer. I don't think it's a walk in the park. I don't think it's hard when you compare it to, say, AZ-104 and AZ-300. I think are some of the harder exams out there, AZ-300 especially, which is now AZ-303. Exceptionally difficult exam, but a fantastic one and a journey I encourage everybody to go through. So you're going to come at it a little bit differently. I just encourage you to go through that post I mentioned, all the links again in the description in the video here. And that will guide you. Test yourself and you'll be well on your way. Okay, so my ask, don't forget to please hit the like button and subscribe so you get notified for the video next week. And then a big thank you again. Use that code AZ900YT. Go sign up for the course now. You'll just need to put your email in, sign up at skylinesacademy.com. If you check yes to the marketing emails, you will get additional coupons for discounts off our membership as well. So I highly encourage you to do that. I realize that's not for everyone, completely your choice whether you want to receive marketing emails or not, but we would love to keep you informed of everything we're doing here. So with that, I would say a big thank you, and I hope you join me again next week as we continue this journey together. You can hit me up at vnexc on Twitter. Would love to hear from you. At Skylines Academy, we love hearing, especially when you pass your exams. Please just send us that. We will try to promote you. We will try to let people know you passed. We will retweet you. If you need help getting connected with people, we want to hear from you, and we'll put you on a list. And if anybody's hiring, we will certainly try to help you out as much as we can. That's there. Please put some comments in below if there's anything else you think I didn't answer. And we will try to hit it again next week. So thank you very much. I wish you all the best and have a fantastic weekend.